Hi all, so welcome to the today's tutorial. So today we will add the zooming text to it. Like right now when we are playing the game and clicking right, so at the right you can see we don't have the blur effect right now, as we were changing the blur variable from this. So we will tweak this from the like as soon as we will equip the scope. Second thing is the numbers which is at the left and at the right, they are not changeable, so we will do that. And there's one more thing: when we are equipped the scope, the notification is coming again and again, which we don't want. So as it was there just for testing, so I think it was added in the begin play if I'm not wrong. Yes, so I will remove that. Compile and save. Okay, so let's start our tutorial. So let's go to the writer. So first let's do the functionality for the uh, metal parameter collection. So where is it? Let me check. So this is under here, metal parameter selection. So we will take the reference of this in the HUD because it will be the best place to do it. So in the core, I will create one variable and expose it here. So let's do that. Head back to the mHUD. In the public section, I will create one property, u property, add it anywhere, and it will be like m parameter u material parameter collection star mpc for. So I'm using it for the scope blur. So we can use it for multiple reasons. Just give me a second. Okay, sorry. So we have created the variable and we can change its variable thing. So if we will hop back to the Unreal side, we have a variable called blur switch. So if it is 1, then the blur effect will come, else not, right? So what we will do, we will go to the switch scope widget. So if the visibility is on, we want that to be there, right? So what we will do, we have an mpc scope blur dot set scalar parameter default value, and here we have to enter the parameter name. So f name, the parameter name is the blur switch, comma, here we have to apply the value which is 1, and when we are removing it, what we will do, we will again access it and we will put the value to be 0. The next thing is to put the null check. So if mpc scope blur is true, then do that. Copy and I will paste it here. Simple. So this is the first thing. Let's check if it is working fine or not. Let me hop over here. Control B. It should be pretty quick. It is taking time. Okay, so I have got the error. So I think I do know what's the reason. So let me hop back to the rider. So the first thing which I will do, I will get the parameter collection instance first. So then we will go forward. So to do that, if it is true, sorry, you material parameter collection instance, we do want that, yes. mpci scope is equals to get world dot get parameter collection instance, and here we have to put the collection. So collection is the one which we have created. So if I'm not wrong, let me do that. mpc scope blur dot set scalar parameter value. Okay, set a scale parameter value for the scope. And we can do one more thing. Let me put this thing at the top. That if we do want that, just give me a second. Okay, delete this too, enter it here and close it here. So for the MSI scope, uh, we want 1 and we want 0 to be here. PSI scope. Okay, I think it should work fine. Control S, Control B again. Okay, let's check. Okay, now my right button is not working. Have I done something wrong? Okay, there is one more thing which I think it is not working because we haven't checked it. So it is always a good idea if something is null, like if it is not true, then in the else part we can add uh, add something to it, to like the debug message, like uh, material parameter collection is not defined. It should work right now. Let's check. Right click, see, it is working fine. Okay, so first part is done. Second part is uh, to set the text. Like at the left we are setting some zoom thing, and at the right we are setting the distance between us and the target object. So let's do that. So for this, this will be the part of screen which we have created. So go to the switch scope widget. We were there right now, by the way. So in the use scope screen, so this will be the uh, main context here. So if we will go to the UI scope screen, let me delete this. This is from the testing part. So if we will hover over this 16, so it is TB underscore FOV. Okay, so it will be the public function u function, and it is blueprint callable too. We can do that. Void update zoom factor, and it will be the float. Next thing is the blueprint callable, same, void update distance to target, float again, distance value. Alt enter, generate definition by declaration, just press OK. So these are the two things. Okay, so first thing I forgot, when you were when we have included the uMaterial parameter collection, make sure that these two these two header files are included. I'm using the smart IDE, so it is automatically adding these things for me. Just make sure that you are doing that too. Okay, so for the zoom factor which I'm using, it is a TB underscore FOV. So it is a zoom factor, right? So TB FOV, set text, string, sanitize float, zoom factor value. Okay, it is expecting f text. Okay, let me do something like this. F text. No, let me use the function then. F text from string. This should do the work. Same thing, we need to use the distance. This is the distance value which we will use, and this should do the task. Let me head back to Unreal, Control B. Okay, it's updated. Let me try. uh, in the scope screen, the function which I have created, give me a second, it was the update zoom factor. Update the zoom factor. Let me check if it is working fine or not. Yes, it is working. It is giving 0 for us, and same with the distance if we want to check it. Update distance to target, put it to 0. Nope. Distance to target. Okay, we are using the same variable. Let me check in the designer part what's the name of this variable. This is focus distance. So tb underscore focus distance. So I think it will be it will do the task. So the next thing is how we will calculate the distance between our target and the distance which we are doing. So this is the first. Let's code that functionality just to have a check if that updating functionality is working or not. Yep, it is working. So let me remove that code from the screen, compile and save, as everything is working fine as expected. So let's go back to the pawn class. Here we will uh, write the function. So it will be the private float distance to target, and float get zoom factor to target. Okay, the alt enter, generate the declaration on. Okay, and what we will do inside the tick, we will be updating these values, because as soon as we will equip the weapon, these two things will be started calculating. Equip here, if it is true. Okay, so if our equip functionality, like this equip state is turned on, so weapon equip state is true, then we will call these two functions, like distance to target and zoom factor to target. Let's calculate these two first, then we'll come here. Okay, so for the distance, what we will do, we will like, if let me draw, like this is the destination, this is where we are standing. From the camera forward vector, we will just take some big value so we can target something, and for the reference we will use the camera. So this is quite simple and the standard way to do it. So the camera. Okay, so here you kismet math library distance, we want vector distance, so we want to have the two vectors starting in the ending. So first is the camera, obviously, so camera component dot location, I think it's the get component location, and second is the target one which we are locating. So what we will do, so this is the camera component. Yes, so f vector camera component dot get world location plus camera component dot forward vector into, so I am just putting some high number, as like it might be a possibility that we are targeting very far object, that is I am taking a very high value. I don't think we need that much, but still just to be on the same in the positive side. So this is the target location, and and get world line trace by channel, single trace single by channel, yes. And here the out f hit result, let me take it, f hit result comma start is the camera location only, camera component dot get component location, component location comma, here's the end location is the target location. I will change its variable name and location comma comma, here's the e collision channel which we do want to use. We want to use the visibility, just use visibility channel, nothing else. And this is it. And if so, in here we will be targeting the hit result dot impact point. Okay, we will return it. This is giving us triple. Okay. Just to have something clean, like readable start location, camera component get component location, start location v distance v. Okay, so this is done, like the distance to the target, and next thing is a zoom factor to target. So it's just the zooming factor which we are using. So there's something called return camera component dot fov get field of view. So this is the field of view. So right now our field of view is 90. Just let me show you something. Go to the pawn. So let's do one thing. Let me have the take function here, event take, call to the parent. This is just for the testing the things out. So this is the camera FOV. So by default it is 90, and as soon as we will zoom in, we will this is the camera angle which is right now getting everything. If we will decrease it by 2, so our value, like which is there in the scope, it will get multiplied. So if it is 90, 90 is like cross 1. If it is 45, so it will be like into 2. So we are just dividing the value. So here if it is 60, so what we will do, we will have few variables here in the private section, float target default FOV, which is, or let's do it in the multiplier way. So default multiplier will always be 1, so the current multiplier by default it is 1. Okay, so what we will do, the field of view we know like the default is 0, right? So let's imagine if the current multiplier is 1.1, like we are increasing by 10%. Give me a second, how can I explain it? Okay, let me open the paint for you. So by default, let's imagine this is the angle. So this the our camera FOV is 90-degree. If we will go like zoom it by 2, like the multiplier is 2, so it will become 45, right? So the 2 which I am saying, it is the current multiplier. So we will increase it by 1.1 if we are zooming in, and if we are zooming out, we will multiply it by zero point 0.9. So how we can get this value? Like this is the multiplier. Like if the multiplier is 2, it uh like then it should like it will move. It should move from 90 to 45. So how we should do that? We will just divide the default FOV with this multiplier number. So if the multiplier is 2, we will just divide this value by 2. It will become 45. I think you should have got the concept. So just for the sake of this tutorial, what I will do, I will change the correct this multiplier. So you property edit anywhere, so we can tweak it in the blueprint. So what we will do, and let me take one more variable. As we already know, like the default FOV is 90. So what we will do here in zoom factor to target, the current multiplier, and here I like 90. So if the current multiplier is 2, so it will become 45. You got the concept, right? Let's do one thing. So 90 divided by camera component get field of view. Okay, field of view, we will just divide it. So if the current field of view is 45, so 90 divided by 45, it will give you 2. So this should do the task. So, and one more thing, so these are just the calculations which is going on. We are not updating anything to the HUD. What we will do, I will expose two functions here. Void update zoom factor, void update the distance. Alt enter, generate definition, yes, press OK. So we already have the object for the widget client for the widget. So what I will do, if it is true, if we have this screen, so scope screen object dot update zoom factor, and okay, we forgot to add the parameters. Float zoom factor value, same thing here, float distance value, copy, okay, this part, these two, I will do the same thing here for the distance. Update distance to target, and here it will be the distance value, copy paste it, just okay. Now what we will do, we will again go put back to the pawn, and in the tick we have the HUD. I will copy paste it, update zoom factor and update distance, and here I will call the distance to target, sorry, uh, zoom factor to target, and here it will be distance to target. Things should be good, I guess. Let's try control B. Let's try clicking right. So the numbers are updating fine, I think, but it is something is fishy. At the left it is saying cross 1. So if we will zoom it, like if we will set the field of view to 45, so this is the 45, like divide by 2, so it should give 2 multiplier, so it is giving 2, so this is working fine. If I will zoom more, divide by 2, again 22.5. So if you will look, like if I'm zooming, see, it is in the zoom state. The photo is really brilliant, but you can get the idea. So this is the main ideas, which is working fine. So let me remove this one, compile and save. Here also let me reset value to 90, compile and save. And for the distance, some uh, because I don't think it was working fine. Okay, let me add to the, because I do think it is hitting something. Okay, so the first thing is the distance is the per centimeter. We want like this is the centimeter, we want it in the meter, so we will divide the value by 100. By 100. Let's do it now, control B. Okay, 172 meter. The value is not updating. I think this is because we are not ignoring our pawn. So let me do one thing. So e collision query param, query, what was the option again? E collision channel and e collision query param, f collision query param, query params. So query params dot ignore. Okay, this is not the property of query params. So what is the next one? F collision response param. Uh, collision response params dot ignore. Query params dot ignored. Okay, sorry, it was the property of this only. Add ignored actor, and I will add this one, comma query params. Let's check that, control B. Okay, yep, it is working fine now. This is great, and it is 1 meter, cool. Okay, so this is working fine. So in the next tutorial we will add the functionality of zooming, like when we will use the mouse wheel for zoom in and zoom out at the runtime. All the values are working fine. Okay, and just for this small quiz type, what you can do at the right, you can see the distance is like going pretty sharp, like after point values to it is like 392403, which is quite high. You can just strip it down to the 2 length. That will be it. Okay, thank you and have a nice day. Please like and subscribe the channel if you do like the videos, and if you have some doubt, just comment it below and I will try my best to solve it as soon as possible. Thank you and have a nice day.